Hi, we'll get started in just a moment here. All right. Hi, everyone. Thank you so much for joining us today for this webinar series on integrating hydrology and geophysics. This is the last in a series of 4 webinars that we've hosted with the EarthScope-operated NSF National Geophysical Facility and CUAHSI. Before we hand things off to our speakers for our discussion today, we're going to give a brief overview of our organizations. We expect that all involved with CUAHSI cyber seminars uphold the CUAHSI Code of Conduct and promote and maintain a professional, considerate, respectful, and collaborative virtual environment. So thank you for being a part of that. My name is Julia Masterman. My pronouns are she, her, and I'm the training coordinator for CUAHSI. CUAHSI is a consortium of universities for the advancement of hydrologic science incorporated. We're a nonprofit organization funded in part by the National Science Foundation, and our mission is to empower the water community and advance science through collaboration, infrastructure, and education. CUAHSI sustains infrastructure to enable research and collaboration by providing a data repository called Hydroshare, as well as other support. By providing this support and infrastructure, we can help researchers formulate and execute their data management plans, be effective data stewards, and meet the requirements of funding agencies and publishers. CUAHSI also provides educational opportunities and infrastructure for student support. These include skill building and science catalyst workshops, a summer institute for graduate students, webinar series and events like this one, a virtual university, and more. Both our data infrastructure and educational opportunities are designed to enable collaboration and interdisciplinary work. And there's a few upcoming deadlines to point you towards. One being that we are accepting module proposals for the CUAHSI Virtual University. The CVU is an interinstitutional graduate education program where professors teach 4-week graduate level courses focused on specialized topics. If you're interested in learning more, please reach out or visit our website. We're looking forward to another great year of the CVU. CUAHSI is also hosting another webinar. The second one in this series with me on will be on April 1st and will be a data skills demo. We'd encourage you to register and join us there if you're interested. And finally, please join our mailing list. That's the best way to keep in touch and connect with us through social media.
Hi, and I'm Emily Zawacki. I'm joined by my colleague Scott Johnson, and we are Science Communication Associates at EarthScope Consortium. The NSF National Geophysical Facility, operated by EarthScope, supports research in the geosciences using geophysical tools. Funded in 2025, the NSF NGF provides instrumentation, data access, and educational resources for researchers, local governments, educators, and students, among others. Incredibly, nearly 1,000 people registered for this webinar series. And so although this is the last session in the series, we hope we can continue to carry some forward momentum. So to that end, there will be a link in the chat, or you can scan this QR code to a shared spreadsheet where you can add your email address and field of research if you would like to find hydrogeophysics collaborators. Just try not to all type in the same row at the same time. You can come back to the spreadsheet later. Take a look at the list in a few days and you may find a new collaborator with a skill set that complements yours. You can feel free to share this link to the spreadsheet with a colleague, but we ask that you please not post it publicly to respect everyone sharing their email address here.
Thanks so much. All right, today's webinar is on building skills and finding collaborators for hydrogeophysics. A huge thank you to our speakers for taking the time to join us today, and to Emily and Scott at EarthScope for all their support throughout hosting this series. Before we get started, a few logistics. This webinar is being recorded and it will be posted on both the CUAHSI and EarthScope YouTube channels. Secondly, we ask that you use the Q&A functionality to submit questions. Please feel free to do that throughout the webinar, where this is going to be a panel style webinar, very discussion based. So as questions come up, please feel free to add them to the Q&A. We have a few pre-formulated questions, but we can move to the Q&A as needed. You can also upvote any questions that come in that are of interest, and we're really looking forward to your participation in this conversation about building skills and collaborations. All right, now to briefly introduce our speakers before I hand it off for them to introduce themselves in just a moment. We're excited to welcome Kennedy Doro. Kennedy is an associate professor and the lead PI of the Hydro and Environmental Geophysics Lab at the University of Toledo. Lily Eligator is the assistant education program manager at the Graham Sustainability Institute at the University of Michigan. Sara Larsen is the chief executive officer of OpenET, an online platform for mapping evapotranspiration at the scale of individual fields. And Sina Saneiyan is assistant professor at Binghamton University working on near-surface geophysics. Thank you all for joining us today. And let me stop my screen share. And we can kick it off with asking you to introduce yourselves, your background in this area of science, and how you found yourself in the role that you find yourself now. And let's start with Sina.
Okay, thank you very much for the introduction. So I am an assistant professor of near-surface geophysics / environmental geophysics here at Binghamton University in New York. Prior to that, I was an assistant professor at the University of Oklahoma for 3 years. I have started my near-surface geophysics journey since I was an undergrad student, so somewhat of a 12, 13, 14, 15 years ago, if I remember correctly. I worked in the industry briefly after my undergrad as a mineral exploration engineer, and I was really fascinated with the ability of near-surface geophysics to delineate subsurface features. So I continued that as a biogeophysicist when I joined Rutgers University as a PhD student, and I realized I'm really interested in the interaction of water with material, as well as microbes with material, as well as anything biologically or engineered related with subsurface material. I started my PhD, and with one goal, I wanted to become a professor. So I think I achieved that goal, and I like it because I love research. I like teaching. Every time I publish a paper or train a student, it's a thrill of like accomplishing something for me. And also, I like this field because you get to go to places that maybe relatively a few people have ever stepped in, and let alone doing anything interesting research-wise. So I love it. This thing is I'm really passionate about it. About hydrogeophysics, the topic of hydrogeophysics was always part of my research for my PhD. I served as the hydrogeophysics chair of Society of Exploration Geophysicists for 2 years. And I have a few papers in the realm of hydrogeophysics, but I let people ask more questions about that. So thank you for having me.
Thanks. Lily?
Hi everyone, my name is Lily Eligator, and my pronouns are she, her, and I am a science communicator, STEM educator, environmental educator, all of the above. I got my bachelor's in environmental science and then my master's in biology, with a focus in biology education, and kind of fell into hydrogeophysics in that world when I was hired as the education outreach coordinator for the Bedrock cluster of the Critical Zone Collaborative Network grant, and spent a lot of really interesting time. I literally had never taken a geology course in my life, and I really fell into it. It was absolutely wonderful. Got to learn a lot about hydrogeophysics and near-surface geophysics, and it was fantastic. Now, after that, I've moved on to be the Assistant Education Program Manager at the Graham Sustainability Institute at the University of Michigan, where I run fellowship programs for undergrad students in all sorts of environmental realms. I'm excited to be here.
Thanks. Kennedy?
Awesome. Thank you. Thanks for inviting me for this session. My name is Kennedy Doro. I'm an associate professor at the University of Toledo, Department of Environmental Sciences, but I lead research practically in the realm of hydrogeophysics, environmental geophysics, combining geophysical imaging and research that really integrate geophysics and hydrology. Currently, most of my research are focused on understanding how soil water saturation and salinity respond to flooding. And those are two key research that some research that we're leading currently in my research group, in addition to groundwater research going on. Prior to joining the University of Toledo in 2019, I completed my PhD, my master's and PhD at the University of Tübingen in Germany. That was my first exposure to this marriage between hydrogeology and geophysics. And this union for me was exciting, right? So where you really can scale hydrological properties or even parameterized model using this type of geophysical quantities that we measure. I've been working on that since then, and tracer tomography was my PhD work, still hydrogeophysics. After my PhD, I delved, like Sina, I delved into the industry, spent about 3.5 years with Fugro, where it was really more of site characterization, monitoring, and remediation using in situ technology, and that took me more into in situ characterization and hydrology, and even geophysics that we were doing was more of in situ. But now that I'm back in research, looking at things more holistically, I'm able to bring the geophysics and connect it with those methods. Well, I'm excited to be here and look forward to answering any question that anyone will have about my work so far.
Thanks so much. And Sara?
Hey, good morning, everybody. Thanks again for the invitation. It is really wonderful to be here with you. A little bit about me. I started working in water with the state of Utah back in the year 2000, right out of college, and spent a lot of time out in the field, spent a lot of time climbing around in some of the tunnels and, dams and just seeing some of the infrastructure, and was really inspired by the engineering around water. Decided to go back for a master's in engineering at some point, and then got really sucked into water policy around water data and whether or not data could be shared openly and transparently across the Western states. So got into the water policy realm probably about 15 years ago. Ended up at a place called the Upper Colorado River Commission as their deputy director and chief engineer, working with the 4 Upper Colorado River Basin states on their Colorado River issues. While I was there, really worked hard to try and understand how to translate some of the science and engineering that was part of my background, and also the data parts, into water policy for better operations in the Colorado River Basin. And while I was there, got to understand a little bit more about how to estimate consumptive use across the 4 states, learned about evapotranspiration, learned about ET models, and met with some of the founders of the OpenET team as they were getting this monumental effort started to start to share OpenET data. Basically just tracked their work and tried to pull it into the operations at the UCRC and with reclamation as much as possible, because we could see the potential that these approaches could have for trying to get a handle on a really hard question around water use, especially around agriculture in the Colorado River Basin. So work at UCRC was really wonderful. Got to know the OpenET team. When OpenET Consortium partners decided that they wanted to have a nonprofit to try and bridge some of the work that was going on for the different consortium partners on OpenET, I leapt at the chance to take on this role to help our consortium partners find out where they want to go vis-a-vis OpenET data and what the next level is like. And very pleased to say that just this last year, we expanded to the East Coast for our ET data. And we're exploring a lot of really awesome regional partnerships. So we're going to talk about collaboration. We're working with Mexico, we're working with Brazil, we're working with Denmark and India on what regional OpenET data looks like for them. And that, of course, has a lot of like cross-pollination and collaboration, both within our team and externally. And it's not free of controversy. Like that collaborative piece is both an art and a science. So just excited to talk about that too.
Thanks so much.
Yeah.
All right, so Julie and I are going to switch off asking some bigger discussion questions for our panel, but please put in the Q&A any questions that you have either specifically for a panelist or to everyone in general. So the first discussion question I wanted to pose to the panelists is if you can talk about and describe a successful collaboration you've had at this scientific interface and the role that you had in facilitating collaborative science. And so you can feel free to either go in the same order that you introduced, or if anybody has a good answer they'd like to start with.
Yeah, I guess I can go first. So I have I think one of the most recent ones successful was here in Binghamton. When I joined, I was lucky to attend some of the seminars at different departments here. And in one of that seminars, I was basically introduced to one of the professors in the School of Industrial Engineering who was doing really cool AI things. And the talk that she was giving gave me an idea of that professor and I can collaborate because she knows her AI and I know my geophysics, and why not just reach out and figure something out? And so we kind of wrote a small proposal, internal proposal, and it was received really well and got funded, and we were able to kind of conduct the research that I had no idea about the AI, and I am assuming that the other professors had no AI about understanding about geophysics, but so far it worked really well, and I think if I did not attend that conference, I would never imagine finding that collaborator at all. So this is like one of the recent successful ones that I have.
I'll go next. My examples will be probably very different from the rest of our folks, because I work a little bit outside of the research realm, but I truly believe that good collaborative science is science that also is done with education and outreach at the forefront of our mind. If we can leave the academic research bubble, science, in my opinion, is much more effective and beneficial. So one of the best collaborations that I've worked on was with the Critical Zone Collaborative Network, where education outreach was really prioritized everywhere. I went into the field, I was in research meetings, I was in the rooms where science was happening, putting me in a better position to communicate that science to the public, but also helping bridge interdisciplinary boundaries. I think one of the things that people don't really understand about SciComm is that not only can science communicators help communicate to the public, they also can help translate in between disciplines. So having science communicators on your collaborative team when there are geophysicists and there are biologists and there are ecologists, etc., can help bridge some of those gaps because we're able to distill science into such small concepts. And in those collaborative situations, I was able to kind of help bridge those vocab gaps and be an effective communicator, not only to the public, but also in between researchers.
Yeah, Kennedy or Sarah?
Great, I can jump in first. Okay. And really, I mean, my example of collaboration, recent collaboration, will be similar to what Sina mentioned. Uh, as a professor, of course, collaboration for us will be more of the research collaboration. Now, of the recent one that has been very productive for me, and I will consider it a success, is a DOE-funded project that I'm currently engaged in that is called the Compass FME. Now, Compass, I'll save you the acronym, but just remember the term Compass. But basically, that project was meant to improve the fundamental scientific understanding, model representation, and predictive capacity of coastal systems. Just like the name sounds complex, you already imagine that it involved lots of other scientists who I probably know very little about what they do. We have soil scientists, we have plant people who are more into above ground, methane expertise, biogeochemists, and all of these other people that I ordinarily don't interface with. And I'm about the only hydrogeophysicist or a geophysicist and hydrogeologist in the team. So you can imagine that our languages don't really, we probably say the same thing in 3 different ways, and I'm not sure whether we mean the same thing. So one of the ways I've been able to integrate, or the way I consider this project a success, is that one, from day one, there was really clear communications of objective goals within the project. And because the project has very senior scientists, mid-career level and junior level scientists, there is clear mentoring structure, right? There were opportunity for mentoring, collaboration, and we meet weekly. So really, the interaction was very clear. And this, in my opinion, was the major driver of the success, or major hinge of our success in this team: communication, mentorship, and really clear objectives and goals, right? And also this feedback mechanism that we share our results. We do team science, so meaning if you're coming up with a research idea, you want to publish it, you've got to share the idea, and those who want to hop on it could really join. And before you say, you start with an idea and the idea grow. Sometimes the idea even grow beyond what you had thought about, and it becomes overwhelming. But generally, we're able to manage that. But that's one way I would say that I've enjoyed this team science, and I mean the project is still on, and I'm enjoying it. Working with diverse scientists, and I have the opportunity of bringing in this geophysics and hydrogeophysics perspective, which really help in scaling some of the in situ measurements that the soil scientists or the biogeochemists measure. I'll stop there.
For successful collaboration, I almost want to point to CUAHSI itself. What an incredible organization you guys are operating within. And one of the things that I've enjoyed over the years with CUAHSI is seeing them grow, and then also have developed like really mature governance frameworks, and like your code of conduct is incredibly helpful. That kind of clarity around how you're going to operate is really amazing and wonderful. And when I think of like the OpenET Consortium partners, which are a group of scientists who came together to work on the question of ET, they also have that have the responsibility and the impetus to set the stage for collaborative discussions amongst themselves on this like shared project. So that's one, CUAHSI, the OpenET Consortium partners, I think that's what I would highlight as successful collaborations, and then how these collaborations really facilitate dialogue amongst their members and even externally about what it is they're trying to achieve. One other successful collaboration kind of gets back to the points that our folks have made already, which is having that outreach component is really wonderful and valuable, especially if you want to grow. And attending conferences is incredibly helpful. Like walking around in the poster sessions is really wonderful. Working on rapport with folks individually, and one of our most recent successful collaborations at OpenET has been working with the folks at the Data Climate Agency in Denmark. We met them at AGU. They came and saw an OpenET presentation, and they were like, this could be so helpful and impactful for our country and some of the other Nordic and Baltic states in understanding flash droughts and ET anomalies that they had experienced over recent years. How about we meet to chat and just see like what that collaboration might look like? And so we had some kind of, nascent Zoom discussions, which are really awesome. And everybody loves Zoom. It's incredibly helpful. And then we got to meet in person. And I just can't express like how wonderful it is to actually meet in person. That sounds kind of silly on a Zoom call, but anytime you have a chance to actually facilitate an in-person meeting and have people go to dinner together or just chat about a project interpersonally, that's just incredibly valuable too. And that I would actually cite that as kind of a pivot point for our partnership on that particular project. So facilitating dialogue using like really clear direction and good governance, and then trying to facilitate relationships both through Zoom and in person, I find are really valuable.
Thank you so much. Also, thank you for the quasi shout out.
Got it.
You all kind of mentioned bits of this in your responses to the previous question, but do you have any practical advice on how to find collaborators, where to start, especially if they're outside your discipline or scope? If we mentioned finding people at conferences or other ways, or if much of our audience are students, do you have practical advice if you as a researcher find yourself in a collaborative or team science project, how to navigate that? So either how to find collaborators, or if you're put on a collaborative science team, any advice as folks navigate that? And let's reverse the order. I'm gonna throw it back to Sara.
Okay. Yeah, great. Like the example I just cited of meeting people at conferences, it takes a lot of energy to chat with a lot of people. I mean, if any of you have been to AGU, it's a pretty intense event. But being willing to put in the time to follow up with folks and develop relationships over time. And you never really know exactly where those collaborative opportunities are going to come from. So you're always going to be like seeding relationships and ideas with different people. Never take that for granted. I think every once in a while visit with people, and then years later they're like, man, I came across this project that was just perfect, a great fit for what it is that you're trying to do, and then it grows from there. So just cultivating relationships, cultivating your network, and visiting with as many people in a cross-disciplinary way as possible. One of the things that I tried to do early in my career was to try and be a bridge between our more institutional partners in like state agencies and the data and scientists who were trying to develop tools to help them. Like, we have all of these people working on amazing models and amazing data and different approaches to evaluating things and be impactful, but they're not always connecting with the policy folks. So being able to speak both languages is incredibly valuable. So try and develop your relationships in that multidisciplinary way and be able to communicate at the levels that they find themselves operating in, understanding their constraints too. Like, a lot of folks say, agencies, why aren't you acting faster? Well, they have different constraints than in academia. So just understanding the different frameworks that people have is really helpful. So especially outside your discipline and scope, I find that really valuable. Even things like just chatting with people on LinkedIn. The spreadsheet that you have set up for this meeting is really a cool, interesting way to try and bridge connections. And so kudos to you for that. It's very creative. Yeah, I think that's probably a good summary. I'll pass it to
Thanks.
Kennedy.
Yeah.
Yeah. Okay. So I'll jump at it. I'll look at it from this way. How have I found collaboration, most especially as an early career scientist at the beginning? Well, I will acknowledge that as an early career scientist, it's difficult to reach out. So I personally, most of the collaborators I had as an early career scientist, they were, I will not use the word collaborators for them, but they were really more of people who I lacked a skill and I reached out to them to help me, right? I was struggling with using some MATLAB to do my work as a master's student, and I reached out to other people within the sphere that could do it. And of course, as a student, I reached out to people that I saw at conferences. So maybe that is not necessarily a collaboration, but I wanted to mention that as a student, reach out, right? Now, I'll share one that I saw a student at a conference. He was doing something on the coastal interface and had no idea about geophysics and just walked up to me and said if there was a way he could integrate geophysics, and he was thinking how he could rent equipment. And I just told him that, well, you don't have to buy one or rent one. Why not just talk to a geophysicist who, if he finds the project interesting, is going to come with his equipment and do it. That way you're not buying, you're not renting. So I think he was somewhere around New York, and I was supposed to do it for him from Toledo. But somewhere along the line, I introduced him to other colleagues that were closer to his place, and they took the project from there, even though I did not continue with him. I hope that they continue that collaboration. That's another classical example of you reaching out. Another way I have found collaboration is at conferences, like others have mentioned, right? Like Sara mentioned. At a conference, I shared my results, and this senior colleague came up to me and started asking questions, started interacting, and asked me, did you look at the IP signals? And I said, well, you know, because I didn't measure the IP. Do you know you can measure the IP signals? I don't have the equipment. Oh, let's talk about it. And that was how I started checking IP signals. And that turned into a collaboration, published the paper, we became co-authors. So really, maybe let me stop it there so that others will chime in on it, but really reaching out, presenting, taking advantage of those questions, right? When I present now at a conference and people are asking me questions, I do not see it anymore alone as a way to show what I know. It's also a way to reveal gap in my work, and I don't have to know everything. I'm going to ask the person who is asking me the question if he has a solution, and let us work together on it. Let me hand the ball over now to, I think, Sina or Lily.
Yeah, I think the question of how do you find collaboration is a very good one, especially because you have to really put yourself out there to build a network of people, and especially now that many institutions are requiring broader impacts to be part of really big grants and grants that you want. I think a lot of folks are wondering, how do I fill out those broader impact sections and proposals? How do I make this bigger? And I know this is a different lens from everyone else, but I think it's important to talk about like when you're writing a grant and you need to fill in your broader impacts and you're feeling a little stuck, there are people who do this who can help. And a lot of universities have outreach offices, education professors who do a lot of broader impacts work. But I think another tip is to really think more broadly about who potential collaborators can be. Think outside of universities, like think about CUAHSI, for example, or EarthScope as potential collaborators in places, but also local community organizations, museums, nonprofits. Another huge collaboration tip is if you have funding, if you are thinking about getting funding, um, putting those funding details in your proposals and your outreach to potential collaborators, having a full understanding of what your funding scope looks like is great. I talked to a lot of community partners who researchers approach them at the very last minute and say, hey, do you want to do this with me? I have no money and no time. And that's really hard for community organizations to get on board. But if you call them months in advance and say, hey, I'm planning on submitting this proposal, for a grant that is this much money, and I would like, if potentially we could work on it together, I can provide this much funding, and I would like this much work, hopefully, that you could help me with. That is wonderful. And community orgs that I work with and have worked with really appreciate it. So just tips on collaboration outside of the academic sphere. I think that's great. And yeah, broadening your horizons on who you think could be a good potential collaborator. There are lots of great folks outside of the academic world that are ready to do really cool work.
Thank you all. These are really great advice. So for me, I'm gonna say sometimes you don't have to reach out to people. Sometimes people will reach out to you, and how to do that as an early career or a student, it's very difficult. But you have to be volunteers in your scientific or non-scientific organizations that you think you can do anything. Any organization looks for volunteers. If you're part of AGU, go to your section, say, I want to do something. How can I contribute? Can I be part of your newsletter, write something, find something for your newsletter and put my name out there? Eventually, people will know you, at least your name. And throughout this, we'll reach out to you. So you don't always have to reach out to people. That would be very difficult to do. But if people know who you are, they will reach out to you. So that's one of the ways that worked really well for me. When I was a PhD student, I volunteered to be involved in our chapters, Environmental and Engineering Geophysical Society chapter at our Rutgers University, as well as the SEG student chapter. So that's how I put my name out there. And then as an early career, I volunteered to create this hydrogeophysics subsection within the SEG's near surface technical section. All of that kind of put my name out there. So now people, oh, this guy, all right, he knows something about this topic. Let's reach out to him. So this worked really well for me. And I think it would help early career people as well if they try to volunteer some of their time for these kind of societies. Regarding conferences, another thing that helped me a lot is just not to be afraid of looking at topics that are completely outside of my area of expertise. So at AGU, I don't mind going to those poster sessions that are completely irrelevant to near surface geophysics or hydrology or something like that, and just wander around. Maybe some topic comes to mind that looks at geophysics can help. So that helped me a lot.
Okay, so kind of switching from practical advice to a little bit of a retrospective. So having kind of been in this space, I'm curious how you've kind of seen the field of hydrogeophysics change over the past, say, 5 years, and where you see it going over the next 5, especially if somebody's student in early career and kind of curious about the state of where the field has come and where it's going. And feel free to kind of bounce off each other. We don't have to go in order or get direct responses from all.
I'll jump in. We think a lot about where the future for evapotranspiration data might be. That's not necessarily the hydrogeophysics is, more hydro than geo. But I think generally speaking, in our field, in terms of understanding what's happening out on the ground vis-a-vis water use, especially in water-stressed areas, that we hope to see a refinement of data and more ubiquitous data, more remote sensing data, more platforms that can help inform us when we don't have good coverage for remote sensing. And then having things be tied to measurement and monitoring in the ground, and having more supportive data streams that work together. And of course, everybody is really big into how AI can help us manage those kinds of big data questions. So probably, incorporating some of that machine learning and algorithms into how those things tie together. And the ultimate goal for that, at least for OpenET and for water use based approaches is to be able to operate and be more efficient with the water that we do have, and to support and sustain an accurate evaluation of water use, and support and sustain programs that help us manage that part of our water budget better. And trying to understand how our climate is changing and how that's going to impact ET in the future is a big push for us as well. So those are just some of the ways that I see things changing over the next 5 years in my space.
Yeah, I can hop in as well, like say that, I mean, I will summarize it maybe in two key phrases and say that the hydraulic parameter estimation and being able to quantify the uncertainties that are associated with these parameter estimates, it's something that we still need to push the envelope, and I'm seeing a lot coming. While you may think about it by revisiting our petrophysical models or integrating deep learning or machine learning informed models into it, we're already seeing it. But the goal for me, or the way I see it, is really the fact that we want to really zoom in more. Instead of qualitative imagery, we're expecting to see more of quantitative parameter estimation. And the second part is really process monitoring. So we're seeing that the technology is already here, that we can deploy geophysical equipment now, ground-based or any other approach that you're using. If you're using a remotely based approach, we now have autonomous time-lapse systems from GPRO to resistivity. You can install those systems in the field and leave them to monitor data continuously. So hopefully we are getting to the point of really improving scaling of parameter estimates or monitoring of hydrological processes. And of course, like Sina, hopefully we had mentioned earlier, you see that hydrogeophysics is gradually moving into biogeophysics. And now maybe we invent a new word that is going to really be hydrobiogeophysics, right? That's how I'm seeing it.
Okay, I go next, Lily, if you want to go. All right. Yeah, for me, I think Kennedy touched on a very important thing. I still feel there is a disconnect between the industry and academia or research, basically, in the field of hydrogeophysics. And that comes because of the sheer uncertainty that we have in our qualitative geophysical data. If we had a very nice workshop, I think a couple of years ago, hosted by SEG about dealing with the uncertainty in hydrogeophysical and hydrologic, analysis, and that was a really good start to kind of try to, bring industry people and research people together and kind of discuss, okay, what is the problem that we want to address here? Us researchers, we want to, dive deep into the cutting edge part of the science and try to answer that, but might not be really practical for practitioners. So having these two groups together would help a lot. So I feel like in the future we will have more of this across different societies and different organizations, to kind of try to kind of bring these people together and try to answer of how we can move from qualitative analysis to quantitative analysis. I think most of the geophysics, at least in part of a non-research hydro, is used for groundwater exploration, not much more than that. And when you deal with the something other than that, people seem to be reluctant. For instance, in New York State, landfills have to have monitoring wells for leachate analysis. And I can guarantee most of them have no idea that you can actually use geophysics to kind of monitor the leachate transport easily, because so many papers are out there proving this works, but no policymaker at least have thought about that, or I don't know, try to implement it as an pilot scale site in one of the landfills that we have in New York State. And when you go to one of these landfills and tell them, oh, let's do that, and as Lily mentioned, I'm going to write this proposal, let's work together. I feel like there is some reluctance here between these people and not just landfill, I mean like industry or government agencies and geophysicists, because they still don't trust the data or the results that are produced from research or academic, settings.
Yeah, I think bouncing off of that, which is a very good point of the distrust sometimes that's between scientists and practitioners and vice versa, is that it's a communication problem in many ways. And I think in a lot of newer, relatively fields like hydrogeophysics, there's this need to explain, like, why is this important? What do we do? Why does this data matter? Why does collecting this data in the way that we do, why does that matter? And so I think I don't know where we're going from here necessarily, but I think it's important to look at the communication and the outreach portion to help solve some of those icky problems and sticky problems we have between practitioners, nonprofits, researchers, et cetera, et cetera.
Thanks, everyone. If the audience has any questions to pose to our panelists, please feel free to post those in the Q&A. But for now, kind of more of a question potentially to the researchers. How do you go about finding a question or a problem to solve? Do you lean towards a place-based approach, a process-based approach? Are you tools and methods driven? Could you speak a little bit to how you go about choosing what to say yes to?
Well, I started as an early career. I probably was more method-driven approach, right? I knew I was a geophysicist, and what can I do with my geophysics? And I started looking for ways I could write grants to to apply those methods. But ultimately, what I have done so far, the way I have my career has evolved so far, is I'm at a point where I think more from a process-driven approach, right? I really ask question on where is the gap? What do we not know much about that we want to know that I'm interested in? Really, start from my interest, right? So what is that thing that that we need to know more about that I am interested in? And that's where it starts coming from. That's where my question starts coming from. So let me pause there because of time. Maybe let Sina jump in, and if there are clarifications, I can come back.
Go again.
Yeah, go ahead. Yeah, if you like.
So I think as an educator slash researcher, one thing I was sometimes you don't know anything what to ask. So it's really cool to have like an open-ended question in your class or your audience and tell them just come up with the ideas and see if that's something that you can help answering. So this has helped me a few times in my classes as I had no idea about certain things that are happening, and hydrogeophysics could be the answer to, for instance, and that helped me a lot in finding collaborators among my class that taking a certain course with me, and it's not always me who comes with the question because I might not even know that question existed. That's one way, just to talk to people and ask. So what do you think? What problems do you have? What research topics are you interested in? Let's discuss that.
Thanks. Sara or Lily, do you have anything you want to add?
I would just add that I do think that sorry, one moment, I gotta sneeze. The way that OpenET was framed at the very start was, is this an issue for people? And vet the question of whether or not evapotranspiration data would be helpful both across the sciences and within institutions that may have questions about that. And the consortium partners reached out to a bunch of folks that they knew in different state agencies to test that question, and ultimately decided to move forward with it. They could see that this was a significant gap. So in that way, it was more of a process oriented project from the get-go. And we even had a pretty robust engagement with people on how to present, whatever the solution was going to be. Asking people like, what does it look like? How do you need this information? How does it tie into irrigation efficiency, or how does it tie into your watershed accounting? And trying to customize the way that we were doing it with a user-centered approach. Nowadays, because now the platform's out there, and because it's open data, what we find is that we encounter lots and lots of place-based things that come up through our helplines, from people reaching out with specific questions about our data, lots of questions about how well do these models perform for my application. And so I'd almost say that we've shifted from that process-based development to folks coming to us and saying, hey, it's doing well here, or it's not doing well here. What can I do about bias that I'm seeing, or what can I do to try and understand how this is comparing to my meter data? Those kinds of location-based and kind of use case-centric projects. Now that we've expanded to the East Coast, and we're a little bit away from the arid West, I think a lot of our issues will change to some of the eastern part of the country's issues around water, and maybe even like a shift toward forestry and natural landscapes as opposed to like irrigated croplands in the West. So maybe that just the underscore of that is to be nimble and shift where you need to. We started out with process-based, and it was great. It was a really good way to work through our problems. And then as you get more mature, you end up just responding to smaller issues.
Thanks. Yeah, it's good to hear that. It seems kind of a through line here is that, openness and curiosity will serve you well, it seems. And with that, Scott, do we have any questions from the audience to get to in our last couple minutes here?
Yeah, we have a few here. So one question here that anyone could feel free to jump in on. Does the panel feel that we're on the path of being able to generate and represent high fidelity digital twin models that enable collaboration, simulation, cross-domain science? Are there any examples of sort of modeling that is facilitating this cross-disciplinary stuff? I'm looking at Kennedy. Yeah.
So I've heard this concept of a digital twin has been bouncing around for some time now, and the last time I heard about it, it really got me thinking, and I recall two sites that are well studied from the hydrological world. So the Lauswiesen Hydrogeophysics research site in Germany, where I did my part of my PhD, the Boise site, where my advisor also spent some time, right? These sites are well characterized. We have geophysical models, right? I've seen people build and test hypotheses using the models, right, that are developed from this site. So when I think about this concept of digital twin that is coming up, you're just trying to build another model representation that you can do any of these things. And we have these sites. I mean, you can call, I've just mentioned two, like the Lauswissen site, the Boise site. I have a site here in Toledo. The Hanford site is well characterized and the pub data is now published. These are potential sites where we already have the hydrological, geophysical, and even sometimes biogeochemical data for real hydrogeophysical models. If we want to explore this concept of digital twin, right, and test models or test methods with it, these are potentials. That's how I will see it. So I think, yes, we are, I won't say we are there, but we're getting there. We have the resources.
Anyone else have a thought based on that? Okay. So the next question here is, as hydrogeophysics continues to evolve, where do you see the greatest opportunities for new funding streams, or what research directions are most likely to attract investment in the years to come?
I don't mind jumping in here. We've had a lot of experience with different funding opportunities over the years. A lot of our collaborators are within federal agencies and state agencies, and even smaller nonprofits and philanthropic folks. And I think without diving into any of the specifics, just see a transition to more bespoke sets of funding that require, like was mentioned earlier, more cross-disciplinary collaboration and like very strong documentation of impact for project funders. It's just getting more competitive and more challenging. And I think that it's good to be nimble and flexible in the current funding environment. Sorry, I can be a little bit more rosy, but that's just how I'm seeing things.
Anyone else want to add? Yeah, go ahead.
If I add to that, I mean, opportunity for funding in the future, I'm seeing that scaling is going to be something that will be of interest. And scaling, when I use the word scaling, I'm actually seeing that our colleagues at the other ends, the hydrogeologists or the soil hydrologists, the biogeophysicists, they're really improving in either laboratory-based or in situ field-based approaches. Some of the ways we're going to see opportunities in the future is this collaboration with them and bringing in geophysics, new ways that geophysics could help them scale their parameter estimates or their process understanding. That's something that we have to always think about. So if you ask me for research direction, the hydrogeophysicists got to be thinking and learning some real hydrology and some real biogeochemistry, depending on your interest. And that was going to be, in fact, I'll quote something I had, a conversation I had with Lee some time ago, was that the opportunities of the future is going to probably be looking for new ways to use these same old methods. We're just having new ways to use them. I'm going to stop there.
I totally agree with Kennedy, and I think that's what I wanted to say as well. We're past the point that proving the method works. We have to kind of figure out how to use it differently for new answering new problems, and that's where I see the the funding opportunities going. To mention what Sara said, we have to move away from like traditional funding agencies that just do basic science research. I think it's the time to do more practical stuff, and there are a lot of great examples. For instance, Rosemary Knight at Stanford, she always starts her talks with, "Forget about NSF." For instance, you can get much more money from agencies, different agencies, or even private industry or private entities, because they want to find a better way to characterize the hydrology features of the subsurface, and they just don't know it, how they can do it. So it's up to you to reach out to them, and maybe, broadening, the net of finding funding opportunities is the best thing to do. And it can be difficult, honestly, to find non-traditional funding sources.
Definitely. Non-traditional funding sources, foundations, etc., are very good options. And I think one of the things, kind of piggybacking on what both Sarah and Sina said, is that quantifying or being able to figure out what your impact looks like, and being able to talk about that concretely to perhaps people who at a foundation are not going to have the same depth of scientific knowledge that you do, that will be very, very important, especially as we kind of transition into more of those private funding sources, figuring out what impact does this have on the larger scientific community, but also outside of the scientific community, what impact will what I do have?
All right, great. In the interest of honoring everyone's schedules here, we'll wrap up there. But thank you to everyone for joining. Of course, thank you again to our panelists who helped us out today. This was really great. Please remember to add yourself to that shared interest list spreadsheet if you'd like. Copy that link from the chat, open the tab, and add it to your tabs before we close the Zoom call here. And just a reminder that the recordings from this webinar and the previous webinars can be found on the CUAHSI or the EarthScope YouTube channels. So if you missed any of them, if you want to share them with someone else, they are there to find that. So, all right, take care, everyone.
Thanks so
Thank
much.
you.
Thank you.
Bye.